Hi, welcome back to my statistics class. So today we will talk about the standard normal model, Z. So now we want to compare unlike events. Even if the two events are quite different, we can still compare them and using the standard deviation as a ruler. And we can see how many standard deviation each event is from each mean. Okay, that's what the standard normal model for. Okay, so now take a look. Assume that the average annual rainfall in Portland is 40 inches per year with a standard deviation 8 inches. So we know that this is what? We've been doing that multiple times, the rainfall in Portland, which is, I'm going to write it here, Portland has normal distribution with the mean 14 and sigma standard deviation 8 inches. Also assume the average wind speed in Chicago is 10 miles per hour with a standard deviation of 2. So this is also normal distribution. So Chicago, so now let's use another letter. Let's not use Y, which is normal distribution with 10, the mean average is 10 and standard deviation is 2. So see, how do you compare these two? One is talking about rainfall, the other is talking about wind speed. Now they want you to compare. Suppose that 1 year Portland's annual rainfall was 24 inches and Chicago's average wind speed was 13 miles per hour. Which of these events are more extraordinary? So think about our bell-shaped curve. So we know that, okay, this is our rainfall. It's going to look like something like that, really centralized in the middle, which is the mean 14. Okay, so this is our rainfall for Portland. Now I'm going to use a different color for Chicago. Chicago is, we know that the central is 10. That's around here with these two standard deviation. Oh, I'm doing it wrong. You add one You add one standard deviation, which is 12, and then 14. You subtract one standard deviation, which is 8 and 6. So maybe Chicago's rainfall look like this. So how do I compare these two? They look totally different. So basically we need to standardize it. Standardize it, you can think about that. We scale them down or scale them up, make sure that they are under the same scale so that they can compare to each other. That's the idea. Okay? So we use this formula, which is Z equals to X minus mu over sigma. And we will see how much they're away from each other. So we know that, hey, the Z score of the Portland annual rainfall, so when X equals to 24, and then minus the mean, which is 40, over the sigma, 8. So this is equals to 16 over 8, which is 2. So this 2 means what? This 2 means negative 2. I'm sorry, not just 2. Negative 2. So this means Z is 2 standard deviation below the mean. So negative means below, which means goes to the left. Okay, so now let's calculate the Z-score from Chicago wind. Okay, so they say in 1 year, Chicago's average wind speed was 13. So now let's do it. 13 minus Chicago's wins average, which is average speed, which is 10 over the standard deviation. We have 3 over 2, which is 1.5 or 2. So that means what? It's 1.5 standard deviation above the mean, the center. So basically, the z-score is help you to identify how far off that specific variable away from the center. Like for the Portland rainfall, we know that, hey, it's 2 standard deviation away from the mean, whereas the Chicago wind is 1.5 standard deviation away from the mean. So for our standard normal distribution, basically is you try to make the mean equals to 0 and standard deviation equals to 1. So on this graph would be the center would be 0, and this is 1, 2, 3, -1, -2, -3. So now let's take a look. Where is the Chicago wind? The Chicago wind is in here. Let me use different color. This is our Chicago wind, 1.5. That's how far off from the center. Whereas the Portland rainforest is, use this one, is -2. That's the Portland rainfall in 1 year. So let's see which one is more far off from the wind. So when you compare it, we just care about the distance, not just the negative number. So for the Portland rainfall, when we talk about the distance, how far off from the center, we talk about distance, that means we're talking about the absolute value, which is absolute value of -2 is greater than our what? The Chicago rainfall wind speed, because Chicago wind speed is what? The absolute value of 1.5 is 1.5. So that means the Portland rainfall is more extraordinary because it's further away from the center, which is the mean. Okay, so now we can conclude that Portland rainfall is further away from the center, which means it's more extraordinary. Okay, now let's take a look. So when we try to standardize into z-score, there's something that we need to know. First, we don't change the shape of the distribution of the variable. It's always look like a bell-shaped curve. And then second, the changes the center by making the mean of 0. That means we're trying to scale them into the same scale so they can compare to each other. And then the third is the change of the spread by making the standard deviation of 1. Again, that's just like you're trying to scale them onto the same level. Okay, so the normal distribution model is that continual distribution of population is identified as a bell-shaped curve. Normal model are only appropriate for distribution that are symmetric and unimodal. Symmetric and unimodal. What is unimodal? That means they only have one peak, which is in the center. The standard normal model has a mean of 0 and a standard deviation of 1. We denote this with the normal distribution and parentheses 0 and 1. In general, a normal model with a mean mu and the standard deviation sigma is denoted as, for a normal distribution, it's going to look like, we denote like that. But for standardized normal distribution, we use the variable z with a mu1 and with mu 0 and sigma of 1. So this one is the standardized one. This is the standardized normal distribution. The top one is just a regular normal distribution. Okay, so the z-score is given by x minus mu over sigma. So for example, how do we find that? Okay, how do we find the probability of the z-score less than 1.5? So first of all, look, if they tell you that this is z, not x, so we know that, hey, this is going to be a normal distribution with a mean of 0 and then sigma equals 1. Now let's use GeoGebra to find out that. So we change the mean as 0 and the sigma equals to 1. And we're trying to find when x less than 1.5, which is 93.132% from GeoGebra. Okay, the second one is find the p probability of the z in between -3 and 0.5, -0.3 and 0.5. Again, z means this is already standardized. So that means we use the mean equals to 0 and the sigma equals to 1. Get GeoGebra. So we use the middle value one, which is -0.3 and 2.5. Okay, would be what? 13%.94. Okay, so now let's look at another example. So, an incoming freshman took her college placement exam in French and mathematics. So now it would be easier if we make a chart. So he took math and the French. So her score, her real score, is 82 in French she scored 82. And in math, she scored 86. The overall on the French result has the mean of 72 points and the sigma standard deviation of 8 points, while the mean math score was 1868 and the standard deviation is 12. So on which exam did she do better compared with the other freshmen? Okay, so how do you do it? So let's see, do better means how far off he's from the center. Now we can use our z-score. So the z-score of that is x minus mu over sigma. So the variable is equals to 86 minus mu, which is 68, over 12 equals to 20 over 12. We simplify it, which is 5/3. Okay, so for the French, we have z is 82 minus the mu, 72 over 8. So this is equals to 10 over 8. So this is 5/5. I'm sorry, 5/4. So which one doing better? Which number is bigger? So now let's try to draw the graph. So for normal distribution, you will have standardized normal distribution. The center is 0, and the 1 standard deviation, 2 standard deviation, -1 and -2. So now let's take a look. For the math, I'm going to use a green pen. So the math is 5/5, which is approximately here. This is 5/5. And then for the French, I'm going to use a pink pen. This is her French score is 5/4 away from the center. So which one doing better? Do you think closer to the center means better or away from the center is better? Of course, he asks you which one is better. That means ask you which one is more extraordinary. Definitely the further away one, right? So by comparing these two, we know that the z-score of the math is 5/3, which is greater than the z-score of her French grade. So we can say she did better in math. Okay, so that's it for normal distribution. I hope you have fun with this class. Let me know if you have any other questions.